Hello my fellow working class heroes, good day. I am Carlo and welcome to Carlo Excels. These are the objectives of this episode. In this episode, we're going to talk about the most common types of errors in Microsoft Excel. And we're going to talk about syntax errors, the circular reference warning, logic errors, and user errors. When creating Microsoft Excel spreadsheets, errors are very common. It happens to the best of us. But even if Microsoft Excel errors are common, that doesn't mean it's okay. Please remember that, of course, at the end of the day, Microsoft Excel is only a data processing program. Of course, it processes data, but data is not created for data's sake. The only reason you're processing data in the first place is so that you can use that data for decision making. And of course, errors in Microsoft Excel creates errors in data. And errors in data creates faulty decision making. So whenever we have errors in Microsoft Excel, it's actually very important for us to be able to spot these errors before they create lasting damage to our school or our company. On the screen right now are the broad types of errors in Microsoft Excel, and we're gonna run through each and every one of them. We have syntax errors, circular reference warnings, we have logic errors, and user errors. Let's first talk about syntax errors. Syntax errors happen when Excel cannot understand instructions given to it by the user, usually due to a faulty writing or use of commands or functions. This is a list of the 8 most common types of syntax errors that happen in Microsoft Excel. And yes, we're going to define each and every one of them, and I'm going to demonstrate how they happen. And if you know how they happen, you can prevent it from happening to you. First, you have the number error. Personally, I just call this the hash error. Excel displays this error when a column is not wide enough to display all the characters in a cell, or a cell contains negative date or time values. Negative date or time values is, self-explanatory. There is no such thing as a negative date or a negative time. But let me demonstrate how this most commonly happens, especially to teachers, the hash error. So we have here on the screen, LRN using the general format and LRN using the number format. Please remember that the learner reference number is a 12-digit number uniquely assigned to each student. So let's put in here a 12-digit number. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2. 12 digits. If you remember our previous lesson, whenever we enter a number like this, Microsoft Excel automatically converts this into scientific notation. But what if we force Microsoft Excel to actually display the full number of the LRN? So let's try changing the number format first. Format cells, and then let's put number and then decimal place 0. So let's try entering the LRN now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2. And you will notice, of course, that the number is bigger than the cell you put it on. So when you press enter, it displays a hash error. Hash errors are very easy to solve. All you have to do is to make sure that there's enough space in the cell, like so, and you will have your value there. Next, the divide by 0 error. Excel displays this error when a number is divided either by 0 or by a cell that contains no value. For higher levels of mathematics, actually humanity has made strides on trying to figure out what happens exactly when we divide by 0. Unfortunately, we have not yet figured out how to do this with computing. So computers generally still cannot divide by 0, and of course that includes Microsoft Excel. So what you have on the screen is a sample dividend. You have a sample divisor, then you have a divisor that is 0 and a divisor that is a blank cell. So let's try getting a quotient by dividing the dividend and the divisor over here. So if you remember our lesson on basic calculations, all you have to do is you have to click this cell divided by this cell. So 100 divided by 10 is 10. Then let's try dividing the dividend by the divisor 0. Let's do dividend 100 divided by 0. Press enter, and Microsoft Excel displays, of course, a divide by 0 error. Then let's try dividing the dividend by this blank cell over here, and you also get a divide by 0 error. Please take note that each and every cell in Microsoft Excel that is blank actually returns a value of 0 whenever you calculate them. So when you try to divide by that, you get a divide by 0 error. The NA error. The NA error, or the not applicable error, Excel displays this error when a value is not available to a function or formula. In other words, the NA error happens when you ask Microsoft Excel to find data or values that are simply not there. For this example of the NA error, I am going to use a function known as VLOOKUP. VLOOKUP is a very amazing, very useful function in Microsoft Excel. I'm not gonna teach it yet, but I'm just going to use it so that I can demonstrate to you how the NA error happens. Of course, I am going to teach the VLOOKUP later, but I'm probably gonna do it in later episodes. So please subscribe to the channel so that you don't miss that lesson on VLOOKUP when it comes. So say for example, we're trying to look for the student's grade in Filipino. So let's use the VLOOKUP for that. We have here VLOOKUP. We're trying to find Filipino grade in this range, and then we want the second column of that range, and then the lookup condition. So we're seeing here that Microsoft Excel finds the Filipino grade and gives you a value of 80. Now let's try English. So I'm gonna get this formula here, and then I'm gonna change Filipino to English. And you will see that Microsoft Excel will return the English grade as 81. But what if you're trying to ask Microsoft Excel to find a subject that does not exist within this list? For example, we're trying to look up values, the values grade. So let's try that. You ask Microsoft Excel to give you the values grade, and Microsoft Excel simply gives you the not applicable error, meaning Microsoft Excel cannot find what you're asking it to look for. Next, the name error. This error is displayed when Excel does not recognize text in a formula. For example, a range name or the name of a function may be spelled incorrectly. So if you remember our lesson on the average function works like this. If you have, enter the function name, average, and then highlight the range like so, you have, of course, the average of these cells, which is 4.5. But what if I misspell the average function and type in average? If you watch the lesson on average, this actually almost happened to us while we were discussing the subject. So we have here, let's use the average function like so. So that is a typographical error, and then let's have this range over here, and then let's enter that. You will notice that Microsoft Excel gives you back a name error. What this means is Microsoft Excel does not understand the function that you're trying to give it because the function does not exist in its current library. Also, Microsoft Excel gives you back the name error if you're trying to put in a function that currently does not exist in the version of Microsoft Excel that you are using. For example, we discussed before that a very powerful function in Microsoft Excel known as the lambda function only exists in the very latest versions of Microsoft Excel. This is Microsoft Excel 2010 I am currently using. So if we try to use the lambda function here, you will of course see that Microsoft Excel gives you back a name error because the lambda function is a function that my version of Excel does not understand. The name error also happens when you try to call upon a named range or a named reference that you haven't done properly yet in your workbook. I hope you were here during our discussion on named ranges, so let's try to give this range a name. So let's highlight these cells, let's define the name, and let's give it the name 8 cells. Like so. So much so that by using the function, the named range as 8 cells, we can use it in an average function. So let's put here 8 cells. So we're talking about the range that we defined as 8 cells with that name. So if you press enter, that gives you back the average of the average of the values that you put in this named range. But if we use this name 8 cells, which does not exist yet in this sheet, so let's try that, average, and then we put here 8 cells. If you press enter, Microsoft Excel gives you back a name error because Microsoft Excel does not yet see or does not yet recognize 8 cells as a named range. You can in fact try to, after having this, you can in fact retroactively give Microsoft Excel that range. So let's try to define this as 8 cells like so. When you press enter, now you have a proper reference or a proper range that is called 8 cells. So when you press enter, there you see Microsoft Excel now recognizes each cells. Next, you have the null error. Excel displays this error when you specify an intersection of two areas that do not intersect. The intersection operator is a space character that separates references in a formula. The calculation of cell intersections is not typically something that we teachers need, but it is needed in some forms of statistical calculation or engineering calculations. So let me first show you how it works. So as proof of concept, let's first try to calculate the sum of cell A2. So you have a value of 2 over here in cell A2 to cell A9, which has a value of 9 as well. So let's try that. Sum of A2 to A9, and you have an answer of 44. Now, let's try calculating the sum of the intersection of A1 to A9. So this over here, let's mark that blue, and then you have cell A2 to A10 over here. So let's mark that yellow. So you will notice that the intersection between A1 to A9 and A2 to A10, the intersection meaning the cells that they have in common, are cells A2 to A9. So let's mark that, blue plus yellow is of course green. So the intersection of cells A1 to A9, that range, and the cells A2 to A10, that range, how do you calculate the intersection for that? Instead of using a comma in the cell function, you use a space. So let's try that. Sum of A1 to A9 space sum of A2 to A10. So that's how you do it as far as the formula is concerned. So what Microsoft Excel is going to do is, it is going to take the sum of the things in common between the range A1 to A9 and A2 to A10. So when you press enter, you have of course 44, because Microsoft Excel has now summed cells A2 to A9. Again, the intersection of A1 to A9 and A2 to A10. But what if you try to do this with two ranges that do not even meet? So say for example, you're trying to get the sum of the intersection between A1 to A5 and A6 to A10. Now you will notice of course that A1 to A5, let's mark it with blue, and A6 to A10, let's mark it with red, they are mutually exclusive. They don't have any cells in common. So when you try that, sum of A1 to A5 space A6 to A10, when you attempt that, Microsoft Excel is going to give you back the null error, because Microsoft Excel cannot see anything in common between the two ranges that you specified to it. Next, the num error. Excel displays this error when a formula or function contains invalid numerical values. The most common reasons why Microsoft Excel displays a num error, first of all, is when the value is too large. Also, it is when you try to get the square root or the even root of a negative. So, say for example, if you have the number 100 raised to the power of 100, if you press enter, Microsoft Excel, of course, is going to give you scientific notation. So this says 1 times 10 to the 200th power. But what if we try to give Microsoft Excel a horrendously huge number? Say for example 100 to the power of 100,000, like so. Microsoft Excel is going to give you a num error, meaning this number is too large for Microsoft Excel to handle. Now, let's try to get the square root of a negative number. If you remember our lesson on basic calculations, this is how we're supposed to do it. So let's get the square root of negative 100 by doing this. So we get negative 100 and we raise it to the power of 1/2. If you attempt this, Microsoft Excel gives you back a num error. Next, the ref error or the reference error. Excel displays this error when a cell reference is not valid. For example, you may have deleted cells that were referred to by other formulas, or you may have pasted cells that you moved on top of cells that were referred to by other formulas. Once again, the reference error happens when the cell reference is not valid because you deleted the cells, because you cut and paste to overwrite certain cells. So let's try this. I'm going to get the sum of single references of these values using single references. So instead of specifying a range, let's do this. Let's reference all of these cells individually, like so. And you get, of course, the sum of 51. Now, let's try to cut these cells here and paste it over these cells here. If you were here with us during our lesson on cutting, copying, and pasting, you know that this creates a reference error because Microsoft Excel now cannot find the cell references that you previously put here. So you now have a reference error. The reference error is actually one of the most common types of errors that happen to basic and beginner users of Microsoft Excel. If you haven't done so yet, please review our lessons on cutting, copying, and pasting, ranges, and references. We have there a ton of tips for you to be able to prevent reference errors from happening. Lastly, we have the value error. Excel can display this error if your formula includes cells that contain different data types. You can typically fix this problem by making minor changes to your formula. The value error usually happens when you try to calculate a data type that is not meant or not built for that kind of calculation. Say for example, if you remember our lesson on basic calculation, if we try to add these numbers here, like so, 1 plus 2 plus 3 plus 4, you get an answer of 10. But if you try to add text along with the numbers like this, you will already know, of course, if you've watched our previous lessons, that you cannot add text with basic calculation. So if you press enter, you have the value error. So if you're getting the value error, please check your data. Please make sure that the data that you are using is using the correct data type and that you are using the correct calculation for those data types. So those are our most common types of syntax errors. Next on our list, we're going to talk about the circular reference warning. Circular reference warning. When a formula refers back to its own cell, either directly or indirectly, it creates a circular reference. So in this sheet, let's see how the circular reference warning happens. Normally, this is what's supposed to happen. So you have here source data. Say for example, I'm gonna put, let's say the number 1 here. Then it says here C2 plus 10. So let's try that. The cell C2 as a reference plus 10. And it says here C4 plus 100. So let's do that. This cell, C4 plus 100, and then let's do this, C6 plus 1000, so C6 plus 1000, and then you have that number. Now let's try to confuse Microsoft Excel. You see this cell over here, it says F2 plus 10, so let's try that reference, F2 plus 10. And then let's enter the formula here. It says here F4 plus 100, so let's try that, F4 plus 100. So essentially what you're seeing here is you're telling Microsoft Excel, take whatever's in F2, add 10. Then you're telling Microsoft Excel, whatever's in F2, whatever's in F4, add 100. If you press enter, Microsoft Excel gives you the circular reference warning. Why is that? Because this cell is adding this cell is adding what's here plus 100, and this cell is adding what's here plus 10. So in other words, you have a circular addition that's happening. That is a circular reference warning, a circular reference error. In most cases, this doesn't happen on purpose. In most cases, this just happens completely by accident. Because if we allow Microsoft Excel to continue doing that, Microsoft Excel would just keep adding numbers in these two cells until you already have a huge number, and then the universe explodes. So to prevent the universe from exploding, Microsoft Excel is kind enough to stop calculating in these two cells until you can fix the circular reference warning. So this is a direct circular reference warning. So if you have one cell linked to another cell which is linked to that cell as well, let's try an indirect circular reference warning. Let's try this column over here. So you see here I2 plus 10. So let's try that, I2 plus 10. Then you see here I4 plus 100. So let's do that, I4 plus 100, and then it says here I6 plus 1000, so this plus 1000, and it says here I8 plus 1, so this plus 1. So you're now calculating in a circle, this plus this plus this plus this plus this. So let's do that, and you have another circular reference warning. You now have the arrows demonstrating to you that this is now referring to itself in a circle. So of course, again, to prevent the universe from exploding, Microsoft Excel has now stopped these cells from calculating. In fact, The other cells will continue to calculate as normal, but these cells will stop calculating until you can fix the circular reference error. So please remember that if you see the circular reference error, it's not something you should simply press OK on and just ignore. Please remember that it will create problems or it will create errors in your Microsoft Excel sheet because it stops certain cells from calculating. So please trace back your references and make sure that they don't refer to each other in a circle. Next broad type of error, the user error. User errors happen when a formula or sheet is correct, but the end user of the sheet makes mistake in the actual usage of the sheet. So say for example, you are a template writer for your school and you create this very simple Microsoft Excel sheet for your fellow teachers to calculate quizzes. So say for example, a fellow teacher of yours who is not that well versed in Microsoft Excel looks at this and wonders, so okay, I am supposed to put items here. So your fellow teacher simply thinks, okay, my quiz number 1 has a total score of 10 points, so put there 10 there. And then for each and every entry here, she thinks to herself, okay, I need to enter my points correctly. So instead of simply putting there just 10, he or she thinks maybe I should put in the correct number of the correct item, which is 10 points. So he or she puts here 10 points, and then it returns a value error. Naturally, this returns a value error because 10 points, because it has the word points in it, this is considered by Microsoft Excel as text data and not value data. So therefore, it returns a value error. But of course, your fellow teacher, not understanding this, panics and thinks that her computer had a virus or something, and that is why it's not working correctly. Look, I know that is a very stupid example, but what I just want to say is, user errors do happen. Sometimes, no matter how meticulously we design our templates, users do make mistakes in the actual usage of them. Preventing user errors is not easy. In fact, some may even argue that it's impossible to completely prevent user errors. But at the very least, by taking certain steps or certain actions, you can prevent some of the most common user errors from happening. There are certain functions in Microsoft Excel that are built to anticipate errors, like the if error function, the is error logical argument. For those functions and logical arguments, we are going to discuss them in later episodes of this channel. So please subscribe to the channel so that you don't miss those lessons when they come. Another very good way of preventing user errors is by using data validation. And well, again, data validation is a future lesson in this channel, so please subscribe to the channel so you don't miss that lesson when it comes. And of course, in my opinion, the best way to prevent user errors is for you to be a proactive template writer. Once you release your templates to your coworkers or to your fellow teachers or to the end users of your template, please continue to observe their use. Look at them as they're entering their data. You listen to them when they're reporting certain errors, and of course, you educate your fellow teachers or your fellow company mates regarding the use of your template or regarding the use of Microsoft Excel as a whole. And then by using the feedback that you get from the users of your template, you can use this feedback for you to gain a clue as to how to better design your templates in the future. As for me personally, I have more or less a decade's worth of experience in designing templates for fellow teachers, and the designing of templates is actually a lesson in the future in this channel. So once again, please subscribe to this channel so you don't miss those lessons when they come. And lastly, in my opinion, the most dangerous kind of Excel error there is logic errors. Logic errors happen when a formula or sheet is considered correct by Excel, but due to an error by the original author, in other words, you, it does the wrong thing. Why do I consider logic errors as the most dangerous kind of error? That's because there is no warning to logic errors. Microsoft Excel cannot warn you when logic errors happen. Nobody is there to tell you that it happened. You will only find out sometimes when it is too late. What you can see on the screen right now is a sample class record of 10 students and their 10 quizzes. So what we're supposed to do now is to calculate the average of these quizzes. And in this example, let's say that you are marking the absences of students with text data. In other words, you have letter A to connote absences in your template. I hope you were here when we were discussing the average function in Microsoft Excel. If you were here, you will know, of course, that the right function to use in this situation is the average A function. So let's use that. The average average A, and then you highlight these cells here, press enter. So you have here an average of 4. Why? Because Microsoft Excel is counting the 2 A's here as part of the count of elements. So we have here 5 plus 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 5. That's 40 in total, divided by 10 elements, and then you have 40 divided by 10, so the answer is 4. But what if you did not know the average A function? What if instead you used the average function? Without knowing what the average function does and how it does not count text data, you use the average function, and then you have an answer of 5. The reason again that this is 5 is because Microsoft Excel does not count text data when it is counting elements in the average function. So you use the average function, you have an answer of 5, and then you mistakenly think that Microsoft Excel is performing the correct calculation, and therefore you copy-paste this to all other students, and you use these faulty information in the calculation of grades. And that is what's dangerous about logic errors. There is no warning. It looks correct, especially when we're dealing with a huge amount of data and then you use a function incorrectly. It is very difficult to double check it. Microsoft Excel does not tell you that there is an error. Nobody's there to tell you that there is an error. You simply think it's correct. The only way that you will find out if you are correct is if you actually try and manually calculate the average of this. And in most cases, there is just so much data that it's difficult to manually calculate this. So you never find out that there's an error. And worse, you will find out if somebody else tells you. For example, if a student approaches you and tells you that you made an error in the calculation of his or her average, or if a parent approaches you and asks you to recalculate, and upon manual calculation, both of you discover that there is an error. And the worst outcome of a logic error is if you continue on with life without knowing that you committed an error in the first place. In other words, if you continue to calculate grades with faulty information. Now, I know that this is small. This is just a point average of, a point difference of just 1. But a lot of teachers can attest to this. In most cases, 1 point can spell the difference between honor and not honor. Mere decimals can spell the difference between valedictorian and salutatorian. Mere decimals can tell the difference between passing and failing. So as much as possible, we need to be able to prevent logic errors so that we do not make those mistakes. So to protect yourself from logic errors, well, first of all, you have to study Microsoft Excel properly. Make sure that you are using the correct functions for the correct situations. Next, double check and triple check your template. Double check and triple check your calculations. Manually calculate if needed or if possible. And try to explore different scenarios in your sheet. Say, for example, try to figure out what happens if this is blank. Try to figure out what happens if this is 1000. Make those small checks so that you prevent logic errors from happening. And lastly, consult a friend. Sometimes a second pair of eyes is a better check than you. So try to give your template or your worksheet to somebody else and try to have them use it, try to have them double check your sheet, and hopefully you get positive results from them. So that's it for the common types of errors in Microsoft Excel. Once again, I am Carlo and this is Carlo Excels. Thank you very much for watching.